Hello and welcome back. We are doing week 4.1 and we're going to talk about file IO. But more specifically, we're actually going to be talking about exceptions because before we can actually start using any form of file IO stuff, we have to talk about exceptions. I want to just close these quickly so that I have what I actually need nice and clean and ready. That was all from the previous video. Since I'm recording these ones back to back, I do them weekly. Okay, none of that really matters. All that matters is that we are now going to talk about exceptions. Now, we've seen some exceptions. In fact, if you came from my previous video, you'll potentially remember that we saw a string out of bounds exception. But we've seen other exceptions too. We've seen array index out of bounds exceptions. We have seen potentially type mismatch exceptions, or maybe even number format exceptions. So let's talk a little bit about what those all look like. So here's some examples of ways to get exceptions. 5 divided by 0 would give us an arithmetic exception. An array value that doesn't exist gives us an array index out of bounds exception. Trying to parse an integer that's not actually an integer gives us a number format exception. And if we make a new object, but never actually use the new keyword, so we just make the variable is null. And if we say x.age, we're going to end up with age being like trying to call age on basically null. So null.age, and that gives us a null pointer exception. So let's just look at what some of these look like and what prints out when we get them. Public class exception example. Okay. Let's start with our main. So if we try to do crazy math, double math, 5 divided by 0, you can't divide anything by 0. Let's see what happens, shall we? Java star, oh, my silly bar is in the way again. Hide star.java. Okay, so that had no problem. And exception example. Okay, right there, we can see what happened. We can see that we have an exception in the main function, java.lang.arithmetic exception. So that's the kind of exception that we got. If you remember from keyboard input that we did a little while ago, and we had to do like an import of java.io, or no, yeah, java.util.scanner is what we were inputting, I'm pretty sure, importing, pardon me. And that was like a library package that we had to bring in. Java.lang is another package. This one has to do with the language. And we have an arithmetic exception, and it says divide by 0, and then it tells you exactly where it happened. Exception example dot main. So in this class, in this method, on this line. If you had more program, it's possible that this output would be even longer, but what we're looking for is always right at the top of the output, because that's going to be where our code actually broke. Even if there's lots of calls coming all the way down, that's just our runtime stack all being laid out nicely for us. So let's look at those now. Let's talk about them. So each of these exceptions are objects. So if you remember from week 2, I believe, I think it was week 2, I was talking about capital O object and how everything lives underneath this capital O object, and how objects are things like string, person, and they live on the heap. They live in heap memory. They use the new keyword with the string being an exception in order to initialize them. So now exceptions, just like these, arithmetic exception, array index out of bounds exception, they all start with a capital letter. These are all types of exceptions, and they're all objects. And since they are objects, since they are type, like you can make an object out of them, so they have a class behind them somewhere hidden, just like we have a person class behind our person objects. They do have attributes and they have methods. They allow us to get the information we need out of them, like the line number that it happened on, like the runtime stack, like a print, like an error message, all those good things. And we can even write our own exceptions, which we're not going to write our own exceptions like like literally like Lauren's exception equals a new Lauren's exception. We're not going to do that today. You're probably going to see that next year. That is not part of this course right now, but we are going to be able to make new instances of built-in exceptions, and that we will be doing. So like a new arithmetic exception or a new number format exception. All right. So just like we have that big O object umbrella, and we had things in there like our equals method and a toString, and they didn't really do anything helpful for us, but they were there, and everything that's an object fell underneath that umbrella and was being protected from the rain by that umbrella. There's actually also an exception umbrella. So capital E exception also is this overarching class where all these other types of exceptions like arithmetic exception and index out of bounds and input mismatch exception, they all hide underneath the exception umbrella. And then because there's this umbrella, we have access to other methods. So we have access to a method called getMessage, which will tell us what happened. We have access to .print stack trace, which will print out to the program that whole long stack trace of debugging information with all the calls and the lines that it happened on. And there's even a toString that we can use that prints out exception information. And again, the fact that it has a toString should also clue you into the fact that exception falls underneath the object umbrella too. And of course, there's a name of the exception and a message. And they have constructors. They're literally just objects. So I think I have a picture coming, so I'll leave that for now. I have a picture of what that umbrella situation looks like. But here's a quick example. So here, if we want to make our own exception based off of the exception class, we can just say exception oops equals new exception, and we can give it a message that we want to print out. So we use it just like any other object. And the information about the stack trace is set automatically because wherever this is happening in your code, that stack trace is being tracked by these exceptions. So when all that pours out, when an exception is thrown in your code, that was all happening automatically. There's nothing new you would have to do when you make your own exception. Now, there is a difference between exceptions and errors. There is a different class of objects called error in Java, which is different. Errors are much more serious problems. So exceptions fall under a couple different categories of if you want to handle them, if you don't want to handle them, if they should have happened, if they shouldn't, if it was an error because the programmer didn't do a good job coding, or if it was an error because the user entered something dumb. There's like different categories of exceptions. And not that there aren't from errors, but all the errors are serious problems that show you did something wrong as the developer. Whereas exceptions, there's a little bit more wiggle room around that. Errors, that's typically not the case. Typically when we have errors, it's pretty obvious. In fact, let's just do a quick example of getting an error. Let's make a method public static void snacks. And without thinking too much about this, don't think too much about it. We're gonna have to do this, otherwise we won't get that far. Without thinking too much about what I'm writing, because it doesn't matter, we just care about the output. I'm just gonna call the snacks method, and then the snacks method is gonna call the snacks method. Okay, don't think too much about that. We're gonna worry about learning what that all means later. But just to see an error, we're gonna do it like that. Okay, so all of a sudden we got an error. We go all the way up to the top of this. Oh, it's a long one. Whoa, too far. It's a long one. Right, where is it? There it is. Exception in thread main java.lang.stack overflow error. So just notice that it has a capital E error. It is not a capital E exception. It is different. This is a stack overflow error. So again, don't worry too much about what that actually, like how I managed to make that error happen or what really just happened. We're going to talk about it in a couple of weeks, but we've now seen what a stack overflow error looks like in code. So even though these are variables, like exceptions are variables that we can make, and we can do things with them. That's not typically how we use them. Like we don't pass exceptions around. You don't return an exception from your code the way that you would like return a string or return an integer or return a person. We want our code to be able to do its normal thing, whatever it's supposed to be doing, and tell us if something goes wrong. So let's just flip back to our code for a second, get rid of this crazy example. I'll leave it and I'll just say example of Stack Overflow error, so that if you want to like check that out later, you can. But we're ignoring that for right now. I'm actually gonna I want to make this like really small and out of my way because I'm gonna do real stuff now. Okay, so let's say we had a method that was like get user input number. Oops, that's not how you do things. And we want to pass back the number that the user entered, and then we want to just print it. You entered a whatever. Okay, so that is what we want to do. So let's make this method public static int get input number. That should not be new for us. We're going to do it with scanner, which we've seen, import java.io, no, .util.scanner, I think is what we need to import. We're going to have scanner sc equals new scanner. We're going to pull it in from our console, so system.in. We're going to get the input string input, and we are going to say, we are going to first say enter a number, string input, words, come on, Lauren, words. Scanner dot next line. We'll just bring in the whole line. They're just going to enter a number. We're going to get int result, and we are going to parse it, integer.parseInt, string in, like that, and then we'll return our result. Okay, perfect. So we're getting our input from our user. We're going to ask them to enter a number. They're going to enter in whatever number. We're going to parse it into an actual number because it's coming in as a string, and then we'll return it, and then we'll say, oh, you entered a whatever they entered. We'll just spit it back to them. Let's clear this all out of the way and run this again. Exception example. So enter a number. That 0.0 is still there from the math problem from above. We enter 50. You entered a 50. Fantastic, right? It returned, no problem. Now, if as a user I type 50, my code explodes right now, right? Because I get a number format exception for input string 50, because that's not a number. So we can't format that as a number. An exception gets thrown. So we want to be able to handle this exception, but also allow our code to return the normal value, because we don't actually know what the user is going to enter. We don't want to return an exception and assume that they're going to enter something bad, but we also can't only return an integer, because if we just return an int and an exception gets raised like this, an exception gets thrown, something went wrong. We have to be able to tell the user you did something wrong without our whole program exploding. And so while our code is attempting to execute normally, while it's trying to go through its normal execution path, it might throw an exception. So something might happen that kind of rings the alarm bell and says, hey, an exception happened, like we just saw when I had that number format exception. So basically what we want to be able to do is we want to be able to say if something happened incorrectly, we can throw an exception using the throw keyword. And now this object is automatically going to be passed back up the stack and get caught somewhere else. We're going to talk about what that means in just 1 second. So all methods that either throw an exception or call a method that throw an exception need to have a throws exception at the end of their signature. And it's necessary unless the method handles it itself. So let's take a look at what that actually means. Before we look at the runtime stack, let's look at what that means. Pardon me. So we're going to talk about the try catch block for a second, in a minute, but because we know that this code here can throw a runtime, a number format exception, right? We can say throws number format exception like this. And then we'll be able to do some work up here to try to run the code and catch the exception if it gets thrown. Think about exceptions like baseballs being thrown back and forth, literally. So we can say, oh, it's throwing an exception. We can also say throws exception like this, because remember, this isn't like an umbrella that all the other types of exceptions fall underneath. So we can scoop up any exception based off of this. Okay, so this is how it gets passed up the call stack, is when you put something like this, throws exception, it will move its way up the call stack. So before we actually implement that and run it, let's just look at what that looks like theoretically. So here's our stack. The first thing that happened in our stack, the main method got called, main called method 1 called method 2 called method 3 called method 4 called method 5, and in method 5, something kooky happened, an exception was thrown. So now what happens is method 5 can handle it if it wants, or it can have that throws exception in the header, and it will throw the exception that was the alarm bell back up, like up the call stack. I know it looks like down right now, so that's super confusing, but it passes it to whoever called it. It's like, hot potato, something went wrong, take this, and it throws it at method 4. And now method 4 either needs to catch the exception and do something with it, or throw it up the call stack to the next one, which means that because method 5 can throw an exception, method 4, if it doesn't plan to handle it, needs to also say throws exception in the header, and so on and so forth. Either you can choose to handle it within a given method, or you can pass it up the call stack, and at a certain given point, somebody has to handle it. So it can be main, it can be someone else along the line. It just depends on the program and the structure of your program. So after method 5 threw the exception, the code stopped in method 5. As soon as we hit the exception and we had a new exception get thrown, we stopped. And then method 4 also threw the exception. And then in method 3, it would seem method 3 was ready to catch and handle the exception, and then the program can keep going. This is what that structure looks like. And we're going to go code that up right now, even with that runtime, with that example that we just saw. We're going to do 2 examples. So how do we handle them? We're going to try to run some code, try, squirrely brackets, and then we're going to catch an exception. So if an exception gets thrown in the try part, we're going to catch it. So we can try something and catch something if it gets thrown. All the word, like we can give it a try, right? I don't know. I feel like the words sort of make sense. Only the exceptions that you have a catch for will actually be caught. So if you try to catch a number format exception, but an index at a bounds exception happens, your code is not going to catch that. They're not under the same umbrella. If you say catch all types of exceptions, so if you said catch exception E, no matter what the exception is, it's going to get caught. And that's what we're going to do in some practice right now. So first, let's do that here. We originally had throws exception up here, or throws number format exception up here. But whoops, rather than doing that, we are going to, I just want to move this down. We're going to do the try and catch in here. So let's make this so that we keep asking the user for input until they give us an actual number. So first we make our scanner, and then we're going to make our int results right here, which starts off as -1. We're going to ask the user to enter a positive number. And while our result is still negative, actually we'll say non-negative because then you can enter 0, non-negative number. While our result is less than 0, we're going to ask the user for a non-negative number. We're going to try to grab that number, and then we're going to try to parse that number, just like that. Now, we're going to try and parse it. We're going to try. If it works, great. This works just like an if-else statement. So if it works, the try runs, the catch will do nothing. But if it doesn't work, we want to catch the exception. This extra character here is the variable. So like exception E is like saying string stir in. So E is the variable, and it is of type exception. So we're going to try and catch an exception. In fact, we'll do a number format exception, because NFE for number format exception, that's pretty standard. since that's the specific kind of exception we know might get thrown here. And if that happens, we will print out a message that says, that wasn't a valid number. So we don't have to throw it back up the call stack. We don't have to throw it to main because we are going to choose to handle this in-house. If they entered something that wasn't a number, we're just going to say, excuse me, that wasn't a number. Try again. Okay, let's run this code. Let's clear, let's compile, and let's run. Enter a non-negative number. If I enter hello, it's going to say that wasn't a valid number. And before that failed, before our code exploded, right? If we go right back up here, when I entered 50, our code exploded. And now if I try to enter 50, it's like, no, you're still not getting it. That wasn't a valid number. If I enter -10, that's still not a valid number. Oh, it is a valid number, technically. I have to fix that. Oh yeah, because then it just says while result is greater than 0, and since result is -10 right now, oh, that's good. This gives me more time to do things. Since my result is -10, it's going to say no, enter a non-negative number. So now I can say 10, and it will see that I entered 10. That will be handled appropriately. Now, this method only throws a number format exception if it was like a word, like something that couldn't be turned into a number. But -10 could be turned into a number. So if result gets turned into a number, that's good news. But if result's less than 0, me as a human still didn't listen to the rules. It was not a non-negative number. So here I can say throws new number format exception. That was negative. So rather than my code just continuing like it did previously, like right here when I did -10, I couldn't get out of the loop yet, but it didn't go into the catch because the catch was only running if it was thrown by integer.parseInt. But I needed to also throw if it's a negative number. So if the result is less than 0, I also need to throw a new number format exception. Sorry, not throws, because a method throws something, but if you want to actually do something as the method, you're going to throw the exception. So here we go, throw new number format exception. This line of code, not with this error message, but this line of code lives inside parseInt somewhere, inside that method. Because it's doing that check for if it's a formatable number. And if it's not, it has throw new number format exception with whatever error message it wants. So let's try this now. This should be better. It will still not work for 50, but it should also not work for -10. That wasn't a valid number, but it didn't print my error message. Why didn't it print my error message? Well, it didn't print my error message because look, I didn't tell it to. This throws a new number format exception. When I catch the number format exception, it gets put inside NFE, but NFE is not being used in here. I'm just printing that wasn't a valid number. If I want to actually use that, I have to say exception. Well, I don't have to write it nicely, but exception message NFE.getMessage. So it's one of the, just like I had said previously, there's methods and attributes available to us on these exceptions. One of them is getMessage. So now when I do this, when I do 50, it's going to give me the built-in message that came from the parseInt. So right here, for input string 50. Apparently that's what the message was when I, like, on the built-in one. But now here, if I do -10, I get my exception message. That was negative. Enter a non-negative number, and then I finally did it correctly. So we can see how tries and catches are going to work here. Let's just, we're going to end up going through the slides pretty quickly after I do this example, but I think it's nice to actually see the code. If instead of catching it in here and trying it in here, what we want to do is we just want to be like, not my monkey, not my zoo. We don't want to have to handle it internally. We can just say throws number format exception. And now we don't need to try catch in here because we get to just be all cowboy coding. It doesn't matter. We're going to do our best. And if an exception gets thrown, somebody else's problem. We're just going to pass it back up the pipeline. And then any method that calls get user input, like in this case, our main, this now is going to need to be wrapped up in a try catch because this has to handle it. Try catch. I just copy pasted from below. Because what will happen now is if this parse int throws a number format exception, it basically gets passed up through here to whoever called it. In this case, main called it. If it passes that one, but it reaches this one and it's a problem, this number format exception will go passed up through here to here. And if it gets all the way through without any issues, it will just return result through the normal means, like through the return value. That will come right back up here into the number, and we will print it nicely. Let's give this a quick run so that we can see what it looks like. So when we entered 50, that message for input string 50, that exception got passed back up. It went up to the main, and the main handled it. But notice here what happened. And what happened is our while loop does not keep running in this scenario, right? Because our code stops. As soon as this parse int didn't work, it threw that number format exception right up and out of here because I had no way of catching it. I'm not taking care of it. In fact, that will happen also if I do -10. It says that was a negative number. But again, this while loop never, ever, ever runs now because I'm always breaking out of here before it has a chance to get to the bottom of the while loop and then come back up to the top. The only time it comes back up to the top is if result is indeed greater than or equal to 0, and then this while loop would just break out. This while loop does nothing now. Now that we've moved it, this method, this like exception handling out of here, this while loop actually does nothing. So it really depends when we want to handle these exceptions, it really depends on the functionality of our program, because we can see that by not handling it inside this method, we weren't able to keep prompting the user for input, at least not easily. Now that prompting would have to happen up here somewhere, which no longer makes a ton of sense. The main shouldn't be in charge of that. So maybe it did make more sense to have the try catch down and in here. It just depends on the program and the problem at hand. Okay, so we're going to see a lot of that in the slides now, but we'll just go through the slides quickly. So you can choose to catch one kind of exception, like we were just doing, a number format exception, or you can catch lots of them. You can catch an arithmetic exception, and then the number format exception, input mismatch exception. You can just keep layering catches, just like if else's, exactly the same way that those work, each with their own type of exception and variable name. Each one will be unique. So each catch has to be like a unique exception type. Now there is one trick here. Here's that picture I was telling you about. Here's the exception umbrella. I told you there was an object umbrella, and I even drew it in video 2. And exception was of course underneath it. I had said earlier in this video, basically you have to think of this as like a series of umbrellas underneath each other. Like I'm a mom to 2 kids, and if I'm holding my big umbrella, my kids still each want to hold their little umbrellas under my big umbrella. Literally, that's what we can think about it like. So the exception does have its own umbrella that lives underneath, and it kind of looks something like this. And then underneath the exception, there are other types of umbrellas. We can see where the number format exception falls, which is the number format exception is a type of runtime exception, which is a type of exception, which is a type of object, right? So it kind of propagates all the way back up. Think about it like circles inside circle Venn diagram style. So if we say catch exception E, this will catch all types of exceptions because it catches every single thing that falls underneath that hierarchy, underneath that main umbrella. So when we just say catch exception E, it catches everything that is being covered by this white umbrella. If I say catch runtime exception, RE, it will catch any kind of exception that falls underneath this black umbrella, but it will not catch every exception from this black umbrella. Hopefully that makes some sense. What that means is that if we add lots of catch blocks, the order of the catch blocks matters. just like in if-else statements, where the order can matter, because the first one it goes into is the only one that gets executed. So if your if-else statements are out of order, your if-else-if statements are a little bit out of order, it can really mess up your code execution. It'll go into the wrong one if all the conditions are being met properly. So when we have multiple catches, you want to put the smallest umbrella first. So if we wanted to catch both array index out of bounds exceptions and other runtime exceptions, like you wanted to handle the array index out of bounds exception one way and all the other exceptions a different way, you'd have to first say catch array index out of bounds exception, and then the next one would be catch runtime. Because if you flip those and put runtime first, if an array index out of bounds exception gets thrown, that first catch will catch it and the other one will never run because it only runs one of the exceptions. Okay. Right? When no exception is thrown, just like an if-else block, when we go into an if, the else doesn't execute. So when no exception is thrown and we were able to complete the try block, we just don't go into the catch at all. And we just keep following along in our code with no care in the world. Like if we go back here, after this catch, we can say end of processing, right? And when this all gets executed nicely and we say the catch doesn't happen, we'll just come right down here and do end of processing. Okay, so here we can see our code is running perhaps, so each of these like starbursts I put in as like catalyst points. So your code is running normally, and then you hit a try block somewhere in your code. The code in there starts to run, but now it's listening for an exception. So this is the code. It has to be in a try block if you want to be listening for that kind of an exception. We're listening, and boom, an exception does happen. We skip over that more code, that third comment in the try block, and we move to the catch block, and we go ahead and follow through from there. So we totally skip over the rest of the try because we probably can't do it, because whatever exception we hit would probably be problematic for the rest of that logic. Cool. And then of course, if we make it all the way through the try, do I not have that picture? Apparently I don't. If we make it all the way through the try with no issues, the catch, we just skip over the catch and continue with more method program code. Okay, so you can add a finally block at the end of your try catch as well, and this block executes no matter what. So no matter what your no matter what happens in try or what happens in catch, finally always happens. So even if you catch an exception that inside of it is supposed to explode your code, whatever, who knows, even if you're throwing another new exception, finally will run every single time. Finally, there can only be one finally, and it's always at the end. So something that you may have noticed when we've been running our code is that we haven't always had to write try catches. In fact, we've never done it until right now. And that's because not all exceptions have to be handled by us. Lots of exceptions are not handled by us because it's the developer's fault. Like the developer should have checked that beforehand. Even the number format exception, that's something that we can check on our own with if statements, for example. So things like null pointer exceptions, index out of bounds exceptions, illegal arguments, arithmetic exceptions, there's a bunch of these exceptions that fall underneath the umbrella of the runtime exception. So they're all underneath the parent hierarchy of the runtime exception. Those are all types of runtime exceptions. Runtime exceptions are what are called unchecked, which means you don't need to check them. You don't need to catch them. You can, as we just saw, we did just catch arithmetic exceptions and number format exceptions, but we don't have to is the point. So you don't have to declare it in your method signature. You don't have to put your code in a try catch. If your code throws one of these kinds of exceptions, your code explodes. We've all seen it happen. That's cool. So runtime exceptions are thrown when the user makes a mistake, usually by calling a method incorrectly, like calling person P and then saying p.getAge, but P is null, right? Or when we did 5 divided by 0, or when we try to do integer.parseInt on something that's not an integer. We shouldn't have called that method because our input was incorrect. We shouldn't have called it on that object, on that information, right? So we actually usually don't want to catch these. By catching them, we're probably depriving ourselves of dealing with some debugging issues. That would be a smarter way to handle these problems. However, there are these other exceptions called checked exceptions, and this is really important as we move into our file I/O, because everything under the exception hierarchy that is not under that runtime exception umbrella is a checked exception. Everything else. So if it falls under a runtime exception, you don't have to check it. Everything else you do have to check. So I/O exceptions, which we're going to do in the next video, are all checked exceptions, which means anytime you read from a file, right? File input output. Anytime you read or write to from a file, from to, read from, write to a file, you have to separate, you have to put your code in a try catch. You have to. Or you have to throw from the method that's doing the reading and then catch it somewhere else in your program. You have to. If you don't do it, you can't even compile your code. So you'll actually get a compile time error, because when we're doing file I/O, we need to tell Java explicitly how we're going to handle these different types of exceptions. So check this out here. If we're reading from a file inside of this function here, we have to try to read from it in this one piece, and then we have a catch that will catch an I/O exception and do whatever we want to do with it. So that's one way to handle this forced, this is like the forced try-catch scenario, is we can catch it using a try-catch. But we have a second way that we can also handle these checked exceptions, which is, of course, trying to read from a file and just saying, not my problem, I'll just throw an exception. So the second solution to handling checked exceptions is to throw it. If any method call or action inside of a method would cause an I/O exception, we're just saying, whoever called us can handle it. This isn't my problem. That's exactly what integer.parseInt does. Integer.parseInt does not have a try-catch inside of it. On the integer.parseInt method header, which you can even go and check out on the Oracle documentation, you'll see it says throws number format exception, because it's like, I'm not handling this. I don't know what you want to do with it. You go deal with it. And that's what we can do for a second way to handle these exceptions, is we can just pass it back up the calling chain, and somewhere above us, main or some other method can handle it instead of us. But we did see that this meant that the method would terminate immediately, which meant we couldn't use a for loop, for example, or a while loop. We lost that ability because our method, we just get pulled right out of it when an exception gets thrown in this scenario. Right? If nothing goes wrong, we return like normal. That's great. But if something does go wrong, our exception will get thrown. And if we don't handle it internally, we're not going to return anything from our method, right? We are just going back up the call stack, and that's all we're going to get out of it. You have to handle checked exceptions when using a method that throws a checked exception, right? So how do we actually know if something throws a checked exception? Well, I'm telling you right now that all the file I/O stuff does. But if you don't know what something might throw, you can always go check. So head over to the Oracle website. We can even do that right now, actually. Let's go and do that here. Oracle integer.parseInt, just so that you can see what I was talking about. Integer class right here, Java Platform SE. And where is it? We'll just do Control F for parse int. Okay, so this is the one we normally use, this static method, integer.parseInt. If I click on it, you'll see right here, zoom in. Ooh, that's really big. Zoom all the way in. Where did it go? It was right there. Public integer. Oh no, this is not the parseInt method. Here's the parseInt method. Public static int parseInt. Or this one, where is the other one? That only takes in a number, throws number format exception. So it's in the header. It's literally saying, I don't know how you want to handle this, so you just do it. I don't know. Right? Oh, I put it in here. I'm so smart. Okay, there it is. So last notes on this. Don't use exceptions as an if else. And you really shouldn't be catching runtime exceptions like we did for practice right now, because that's just lazy coding. Actually make if else statements, do it properly. Check to make sure that your objects are not null before you use them, instead of catching these exceptions all over the place. Runtime exceptions are there as a failsafe so that you know that probably something went wrong in your code. You can't just catch those exceptions and then hand in your code or submit it in the real world and be like, no, don't worry, it works. I mean, it might explode, but don't worry, it won't really, because I'm just going to catch all the exceptions and tuck them away. We can't do that. We have to actually code properly. This isn't supposed to be a way to just get lazy with our work, right? So we are going to, so far we've had exceptions that are readily available to us, right? All these runtime exceptions, we don't need to bring in a special package the way that we did for like java.util.scanner. However, in the next video, when we start talking about file reading and writing, you have to bring in java.io. And you can bring in java.io as a whole, which is probably a good idea because there's going to be other classes that we need access to from java.io. So rather than saying java.io buffered reader, java.io.file, java.io.file reader, java.io.io exception, rather than bringing them each in individually, we can just say use import java .io.star, and that will bring that whole book in. All the chapters of the IO book get pulled into our program, and we have access to all of them. And we will see that shortly. So before you move on to doing file reading and file writing, take some time to understand these runtime exceptions for practice. Try and see what throws what. Like try to make your code throw runtime exceptions and see which ones throw in what scenarios. Write those exceptions down. And what type of code made those exceptions occur. Once you've done that, try and think about ways that you could avoid running into these exceptions in the wild. So like what kind of if statements should we be doing to make sure that this doesn't happen in the future? And if you're looking for a place to start, I've listed 6 different types of exceptions here that you can now go and try and make your code throw. And once your code is exploding, try and rewrite your code with if statements so that you can avoid them in the future. Once you've done all that, I'll meet you over at the file reading and writing video. So yeah, good luck with all of your exception making, and I will see you over at the next video.